And I'm James Hall. I'm R&D Manager with Carbon Clean. I'm joined here today by an expert panel to discuss CycloneCC, a breakthrough technology, and the innovative journey so far.
James, I'm Paul Arwis. I work for a company called CLT. We specialise in helping innovative clean technologies get to market.
I'm John Lee from Newcastle University. I'm a senior lecturer in chemical engineering and I'm responsible for a lot of the background research to do with CycloneCC.
And I'm Stuart Duncanson. I work for Babcock, Head of Technology Integration, and I'm focused on industrial carbon capture and storage.
Great, thank you. So Paul, can you tell me a bit about the incubation support that you've been able to provide to the Carbon Clean team to enable them to accelerate in becoming a commercial success?
Okay, well, I'd like to start off by saying that sort of Carbon Clean is pretty much one of the best examples that we're proudest of in terms of our incubation support. We've worked with Carbon Clean since 2014, and incubation support comes alongside government grants, government technology grants to help a company take clever technology and take it to the marketplace. The sort of things we do stretch on the one hand from doing market assessments for companies in particular areas one that you want to develop, to looking at incubation, intellectual property, helping people write business plans, everything that could help a company get a great technological idea and take it to the marketplace.
And in your opinion, what would you say are the key drivers for a technology startup to succeed in developing and commercializing new technologies?
Well, the crux really is, do you have a really compelling idea? So not only a clever bit of technology, but something that really addresses a market need, a pain point that customers out there are actually going to pay for. And once you've got that, I think there are two other things which are critical. One is actually having the right founding team. So Carbon Clean were brilliant in that they had a technical genius and a commercial wizard come together who could really drive the company forward. And that's really pretty much the ideal team to start off a company. And the last thing is, engagement with your customers or potential customers in the future. Getting early traction, talking to them, understanding what they really need. Those really are the three factors that kind of are the fundamentals of being able to get a great piece of technology into the marketplace.
And with respect to CycloneCC, why is this technology coming at the right time?
Well, I'm sure you probably agree that we're about to move into a world of great shortages. We've already seen a huge CO2 shortage in the UK. Energy prices are going all over the place. For many companies, being able to have their own CO2 rather than relying on the market, I think makes a lot of sense, because often CO2 for, let's say, food producers is a very small amount of their costs, but is absolutely vital to actually their production. And we're going to live in a world where energy prices are going to ratchet up and down, and so having the flexibility to be able to use, say, natural gas on your own premises, I think, whilst having very little impact on the environment, seems to me to be a hugely beneficial option that any company should really look at carefully.
For sure. And so Stuart, switching gears, you've worked with us and you've seen CycloneCC in action. What can you tell me about the impact that the technology is likely to have on the hard-to-abate industries?
Yeah, I think the technology is very interesting in the fact that it offers a significant cost reduction and it's modular. When you talk about sort of hard-to-abate industries such as chemical or cement, one of the key problems with integrating such technology is space, and also the fact that often the CO2 comes not just from the energy provision on the site, but also from multiple point sources across the site, because it's a key part of the process. So the ability to offer modular carbon capture technology that can be installed in multiple locations across the site is massively beneficial. And I think the fact that the size of it allows you much more scope and opportunity to do that means that technology is a very interesting option for these types of technologies. The cost reduction, I think, also, as you sort of talk about, in terms of driving CO2 capture for usage is massively beneficial. If you can capture that CO2 at a reasonable price and you're able to use or sell it, then that's a fantastic opportunity. And I think the cost reductions associated with the technology is brilliant.
And how hard do you think it's going to be to integrate this state-of-the-art technology, and how do you think it will change in the future?
You know, integrating state-of-the-art technology is always a challenge, but one of the advantages of being able to run with a modular approach is the ability to install, you know, one module initially, demonstrate that the technology works, iron out any problems you may have with that, particularly when you're using it on an application that may not be, have not been used previously, and you're trying to work through some of those issues, and then seek to scale that with multiple modules. And that's massively beneficial in terms of de-risking the approach.
Yeah, and I suppose along those lines, how do you think the technology adoption will become easier with this modular systems and also moving toward more standardized technology? Is this the right way to go? Is this the right direction of travel?
Yeah, I think standardising technology offers you, you know, significant advantages. You're able to basically consistently manufacture a similar product, which means when it's out in market, if you have particular issues, you're dealing with one key part of that, and you can make those changes. When you're dealing with a carbon capture plant that's been specifically designed for a particular application at a particular size, you know, you can have multiple sites with different valve sizes, etc., different technologies involved. And that's quite difficult to understand where some of the faults and issues are coming. But when you standardise the technology, you're basically able to fault find in one unit and then basically roll that out right across your fleet. You get a better understanding of how your technology performs, where your root cause of failure are, and you're able to basically improve and work on that. And that's highly advantageous. One of the other major advantages will be, I think, moving into the UK space. You're going to have a real issue in terms of site resources, particularly in places like the UK and Europe. So constructing a site is difficult. You're going to have a shortage of staff, and the ability to actually manufacture modules within, you know, an enclosed environment where you can control that manufacture and the quality will give you significant advantages. And as with anything that you standardise, the more you make it, the quicker you get, the more efficient you get, which can only help to drive down the cost.
Exactly. And one of the key features of CycloneCC is a reduced equipment sizing. How important do you think that size reduction is going to be important in relation to decarbonising heavy industries?
I think it's going to be massively important. If you look at industrial sites, they don't have space to burn. It's, you know, space and land's at a premium. So the ability to install technology which uses a smaller footprint gives you significantly more options. If you look at the large industrial providers within the UK or across Europe, often they don't have that space. And if you can offer technology, it's much smaller, it can be modular, it can be stacked, that offers you significant advantages over a specific design of a carbon capture plant. And I think that can only help accelerate the opportunities. The cost associated with that will also mean that it becomes much more applicable to different industries and different companies.
Yeah, and that size reduction, I mean, we focus on that a lot. And John, turning attention to you, you've worked with rotating packed beds for most of your career, and it's a rotating packed bed that's at the centre of the CycloneCC technology. So what is it about these rotating packed beds that make them advantageous for CO2 capture and size reduction?
There are two main advantages. When you rotate the packing, it means that the liquid and the gas involved in this process can move past each other much more rapidly. And so, because they're moving past each other more rapidly, you get good mass transfer between the two phases, the liquid and the gas. And that feeds into the second advantage, which their niche application for rotating packed beds is reactions in the liquid phase that need material from the gas phase. And if you've got a very high rate of mass transfer, then the CO2 can get from the gas phase to the liquid phase easily. So they're ideally suited to carbon capture, and they can handle very high gas and liquid volumes.
And drawing on the point that you've spent a long time researching with rotating packed beds, you've even worked with Colin Ramshaw, who's widely credited as the inventor of rotating packed beds as well. In all of your time working with the technology, what would you say is the most significant development that you've seen during your experience, particularly in the space with CO2 capture?
For a long time, it was a box and it had inputs and outputs, and we only measured really on the inlet and the outlet of the system. And then in the last 10 years, we've been able to look inside using tomography, and that has given us a much better idea about how the liquid behaves inside. And from those measurements, we've been able to develop better packings, and the recent projects we've done have utilised those better packings that have been developed using tomography. So the development of packings has been one of the big advances. So,
and what's the main impact of that? What do you feel we gain from it?
Well, there are one of the operating parameters is pressure drop on the contactor. And if the pressure drops too high, then obviously there's a knock-on effect to the economics of the process. So these new packings have much lower pressure drops. And so that impacts the fan size and the electricity usage for that. And then because of the materials they're made from, they have much higher surface area to contact the gas and the liquid. And so therefore you get higher rates of mass transfer from those packings.
What I find when I'm discussing with people for the first time CycloneCC and rotating packed beds is one of the most common questions I get is around mechanical reliability, because they see there's a rotating piece of equipment. So what would you say, what can you comment on about the reliability of this technology?
Well, you're right. People often confuse rotating packed beds with centrifuges, which operate at much higher rotational speeds. So the first point is really that rotating packed beds operate at hundreds of RPM rather than thousands, and so that's more typical of a pump. And if you think of them as being pumps, then that's a better ballpark in terms of their reliability. So then for pumps, it's all about the reliability of the seals, and basically those seals have been developed for pumps and can be transferred onto rotating packed beds. Of the rotating packed beds that are in operation, there are ones in the chemical sector which have seal lives of 5 years plus, and in the food industry 15 years plus. So I think the data is there that this is a reliable technology.
Absolutely. I think that hopefully helps bring some confidence to the customers as they look to implement this new technology, because nobody really wants lots of downtime, servicing. They want the same reliability that you can have with the equivalent technology, the kind of benchmark technology. So what do you see as the future and the kind of direction of innovation and R&D around rotating packed beds?
I think there are the things you can do to make the absorber smaller again. We now understand what happens to the liquid as it enters the rotating packed bed, and maybe by replicating that throughout the packed bed we can make them smaller. And then on the regenerator column, there's a big opportunity to integrate the regenerator with the heat transfer system of the carbon capture plant and thereby save energy. So I think developments in those two areas will take the technology forward.
Very good. And Paul, what sort of support do you see coming from government at the moment and other funding agencies to support innovation and development in this area?
Well, obviously I don't have any inside track on this, but I think that it's clear that carbon capture is going to be a big part of the mix of energy solutions that we're going to need in the future. And I think the government in the UK and around the world, I think, are hopefully going to get more and more behind it to make sure that technologies like CycloneCC actually get the right sort of market environment so that people will buy them and use them. I think it's one of the main ways that we're going to get out of the potential crisis that might occur on climate.
And Stuart, Doosan Babcock's history in researching carbon capture, you have a test facility in Renfrew, just outside Glasgow, where you've been doing a lot of research in the past. But that facility was mothballed for some time. What's it meant to the team at Doosan Babcock to now be working with Carbon Clean in testing and developing the CycloneCC technology?
Yeah, I mean, it's great for us to see that investment we made. We made that original investment in 2010. We did work to scale up that technology, and we obviously hit the carbon capture valley of death as such in the UK. So it's great to see that carbon capture is back on the radar, that the UK government and other countries across the world are investing within it. And it's been great to have Carbon Clean on board and doing that work at the facility. The technology is massively exciting. Next generation carbon capture, we see real benefits in driving down the cost and offering opportunities, and we're really excited to continue working with Carbon Clean to see that technology commercialised and on sites across the world. It's fantastic.
Thank you. Well, that just leaves me to thank the panel today for joining me for this fantastic and fascinating discussion. That's us from the studio. We're handing over to Cemex, where we're going to be finding out more about their scale-up activities that they're announcing today.